wish we were chasing waterfalls somewhere in North Carolina. And I wish I was holding your hand while your hand was holding mine.
Welcome to another episode of the Tailwaters Fly Fishing Podcast. I'm excited to talk to you today about a research paper by my friend and fellow angler, Jules Silverman. Jules is a retired entomologist from NC State with an analytical mind and a love for fly fishing. Before retiring, Jules performed a very interesting study on trout feeding behavior, specifically around size of prey. The research paper that he co-authored with Brad Taylor is entitled Prey Detection by a Stepwise Visual Template Matching Mechanism. However, Fly Fisherman Magazine recently published a layman summary called Now I See You, How Trout Appetite Shifts from Hatch to Hatch. I'm going to present Jules' work chronologically and as more of a story, but there will be plenty of nerding out too. I encourage everyone to read the Fly Fisherman Magazine article and also to take a read through the scientific paper. Jules' research was motivated by some trips that he took to the Missouri River below Holter Dam. He went 1 year in late July and had an amazing time catching trout on tricos. It was a good enough trip that he planned another the following year. However, this time he went a week earlier. And while he saw that there were plenty of tricos, about a size 24, there were also some PMDs, probably about a size 14 or 16, on the water, and he couldn't buy a fish with any of the tricos in his box. Dejected, Jules went to the local fly shop to ask what was going on, and the owner told him that the fish just hadn't seen enough tricos yet. Now think about that. There's a ton of bugs. The fish clearly ate them the year before in abundance. Does a week really make that much difference? It sounds like that guy either really knew what he was talking about, or he was full of it. Most people I know probably would have formed an opinion and left it at that. But not Jules. Jules returned to North Carolina and devised an experiment with his colleague Brad Taylor to explore what might be going on. The first step was to catch some fish to observe. To do this, Jules and some friends caught 3 brown trout from the South Holston River and transported them back to his lab. I was actually there on that trip. We were staying at the Castaways, but I can't remember who caught the now famous trout. I'd like to think that I at least contributed one, but I would probably have a better memory if that were the case. Once Jules had his trout, the next step was to figure out the food to use in the experiment. It would be pretty difficult to grow a population of tricos and a population of PMDs in the lab. While I mentioned that Jules was an entomologist, I didn't disclose that most of his research has centered on cockroaches. Because of this, he raises them in his lab and has an ample supply of cockroaches at different stages of their life cycle at any given time. And it turns out that at the first instar phase, the cockroaches are about 1/8 of an inch long. These are going to be referred to as the small cockroaches throughout the rest of this podcast. At another phase, they're about 1/4 of an inch, and we'll refer to those as medium. The adult males are about 3/4 of an inch long, and we'll refer to those as the large cockroaches. One major consideration was establishing a baseline for how much food the trout would be given before an experiment. You wouldn't want them to act one way one day when they were hungry, and then another on another day when they were full. So what is full for a 13 to 16 inch brown trout? If you dropped in one cockroach, waited for the trout to eat it, and then dropped in another, how many would the trout eat until it quit? Jules posed this question to my fly club years ago during a presentation on his work. It's been a while, but I think we had a lot of answers in the 15 to 20 range. Well, the actual number is around 200. Let me emphasize that again. 200 adult cockroaches is what a 13 to 16-inch brown trout will eat before it quits. When you're fishing and someone says the fish must be full, just know that that is very, very, very rarely the case. With this baseline in place, the researchers decided that they would feed the trout 50 large cockroaches before each experiment. Now, on to the experiment. Remember the question and the motivation for the study. Fish had been eating PMDs, or large prey. Trichos started to hatch, and the hypothesis was that it would take some number of them to be available before the trout would finally switch and start eating them. The experiment was designed to see if the smaller bugs would be eaten with increasing exposure rates, meaning when more of them were available in the experiment. If the fly shop owner was right, the fish would have to see some number of the small prey before the fish would start eating them. Remember that the fish are being fed large cockroaches before the experiment to make sure that they're at a baseline fullness. These are referred to as the focal prey, but let's just call them the baseline cockroach. Think PMD here. These were compared to the small cockroaches to begin with. Each day, various mixes of cockroaches were dropped in front of the trout, and on successive days, the number of small cockroaches was increased. On day 1, 50 large cockroaches were dropped in front of the trout as a baseline. Then, 45 large and 5 small on day 2. On day 3, 40 large and 10 small. You get the idea. And they did this until there were no large cockroaches being dropped, only 50 small cockroaches. So you would probably think that either the fly shop person was full of it and the fish just ate all the bugs all the time, or at some point the fish would switch over and start accepting the small cockroaches, like maybe at a 50-50 mix. But that's not what happened. Virtually none of the 200 small cockroaches were consumed in the first experiment. It seemed like the trout weren't even observing the small cockroaches as food. The next thing to try was increasing the size of the test food source. They continued to use the large cockroaches as the baseline, but then added medium cockroaches in various ratios to test the trout's behavior. What they saw is that nearly all of the medium-sized cockroaches were consumed. And just to remind people, the small cockroaches are about 1/8 of an inch, the medium are about 1/4 of an inch, and the large adult males are about 3/4 of an inch long. Well, that begs another question. What if you change the baseline from large to medium cockroaches, and then try dropping in small ones? Would the trout eat them then? Well, that's what they did, and it worked. Once the researchers changed the baseline, nearly all of the small cockroaches were consumed. Another cool thing that the experimenters explored was, given how hard it was to get the fish to eat the small prey in the first place, would the fish turn off to them if they didn't see them for some period of time? To do this, they withheld small cockroaches from the fish for 1 day, 2 days, 3 days, 7 days, 2 weeks, to see if the fish would still eat them afterwards. And they did, meaning that the fish remembered the food for at least 14 days. The researchers also tried introducing an extra large prey when compared to the large cockroach baseline. The extra large bugs were about 1¼ inch in length, and it turns out that there was some hesitation to taking these larger bugs, but the fish reacted much more positively than to the small prey. So before we summarize this experiment, let's talk about some of the caveats. These fish were well fed. There was a single food source used as a baseline. The water had pretty constant temperature and flow. There were no predators. Simply, this was a lab environment. But given that, there's still some pretty interesting observations that we can take away. First, trout can eat a lot more than you think. A 13-inch trout can eat about 200 cockroaches and will before it stops. Another interesting observation is that it takes time for fish to shift from eating one size food to another. It takes less time to go up, and it takes more time to go down. The bigger the jump in food size, the longer that shift can take, and the more difficult it can be. The time to switch from one food size to another is alleviated by intermediate food sizes in between. Remember, going from large to small cockroaches was very difficult. Going from medium to small was much easier. And then also, once fish accept a certain food item, they retain a memory of it. They'll keep eating it for at least 14 days. So what are some practical on-the-water applications? First of all, size is a big deal. Remember, these were real food sources getting rejected. If you cast a fly that's too big or too small, it's also likely to get rejected. As it applies out here in East Tennessee, the Holston doesn't have a lot of biodiversity, and there's a lot of small bugs. What that means is if you're bug fishing, it's important to match those bugs. It's important to fish small flies. In other bodies of water, where there's more biodiversity, such as a freestone stream, trout are much more likely to eat food of different sizes, and they may have an easier time switching from one food size to another. That's where you can break out the size 14 prints. Well, thank you, Jules and Brad, for making this research available. Thank you, Fly Fisherman Magazine, for making it more digestible to people who haven't brushed up on their stats in a while, and I hope everyone enjoyed listening. Thank you.
And how that fire's burning hot, but it can't keep up with your touch. The song girl